Hello and welcome to Joseph Data Science for Curious People. In this video, I'm going to be looking at a multi-featured linear regression. I'm going to be creating a model. This is in R, and I'm going to show you how you can do it. So what is a linear regression? Well, linear regression is a machine learning method, algorithm, model that basically takes data. So you can see down at the bottom left of my screen, I've printed out data that I'm going to be using. So I've imported the library readr. The file is called houseprice.txt. It's a famous data set that Andrew and Guy uses and has used on a Coursera course in machine learning. So I've got that loaded here, and then I created my object variable using read.table function. The file is here, header true, and then the separator, that's a comma, and then I've printed the head. So you can see down here the square foot of a house. So the first row of this txt file, the square foot is 2104, that's square foot. Bedrooms 3 and price is that, it's in dollars. So this is a training set of, let's just work out the sum, how many. The sum doesn't matter, bedrooms. So there are 149 rows. So there are 149 data points, if you like, sets, training set. So there's 149, which in machine learning, that's not much. So the model we're going to get is probably not going to be very good, but that's okay. I'm going to show you how it works. You really want to have sort of, perhaps 14,000 rows will give you a better model. The more you have, the better it'll get, generally speaking, although that's not always the case. We would probably also actually want more features. So in machine learning, each of these columns, not this price one, but the bedrooms and the square footage of features, we might want more of them. That would probably also produce a better model. So what you do basically in multi-featured linear regression or multi-featured regression is you have a bunch of these features or inputs. So square foot of a house, bedroom. You might want to have bathrooms if there's a bathrooms, or you might want to have whatever else in a house that may contribute to the price, because the price is what you want. So the price is the y. It's the y, it's the output that you're looking for. So think about, in maths, there is that formula, y is equal to, I'll just use a coefficient b, plus b1 x1 plus b2 x2, and so on. This is the formula for the regression line that we will create. And the regression line, it's a line that we create basically that will fit in the data points, creating the best line through the data that we can use to predict y. So in multi-featured linear regression, we want to predict y, which in this case is the price. So we want to predict the price. So if we know there's a house that has whatever square footage, whatever bedrooms, however many bathrooms, how many garages, and so on, we want to then input those into our model and then get out the price. So we want to predict the price. And the way we do that is by, in a sense, drawing a line through the data. That's how we do it. So that's what we're going to create now. So the way we're going to do this is I'm going to create a few objects. The first one I'm just going to call x1, and that is x1 I'm going to make square foot. x2 I'm going to make bedrooms, and then y is going to be price. So here are our three objects or variables. So there is one, let's run it, and then y, and we get no errors down here. It's all good. Gotta love RStudio. So x1 is square foot, x2 is bedrooms, and then y is the data. So we're actually basically ready to go. So let's multi-featured linear, let's just call it regression. So it may not be linear in nature, so I'm just get myself confused. Multi-featured regression. So multi-featured, there's more than one feature, and we're going to do a regression. So what we're going to do, just taking a look at the documentation over here on my left. So the formula is it's y, and then we do the little tittle, and then we do x1 plus x2. So let me just explain how this works. So if you took a look at the documentation for the lm function, so argument for lm, let's just do that for a second. You look down here at the bottom. So the function, the first argument is called formula. So that's what we've got there. The second one is called data, and then we have a few others. I'm only going to be using formula and data. And the way this basically works is that the y, or the output, the result, the thing you want to predict, that comes first. Then you do a little tittle, and then you do however many features you have. You could have 10 features. In fact, 10 features would probably produce a better result than 2. So, and then our data is equal to data. Now, I don't have to do that, but it's just sort of habit because I have already defined data there. But anyways, okay. So we run it. X1 is not found. Object x1 is not found. Oh, it's a capital X. Small x, is that right? Okay. No errors. Now let's just do the summary of multi-featured regression. Now what we're going to get this printout here. So the first line shows us what we've just called. The residuals are basically, they're quite important. They basically show us it's the error between the predicted and the actual. So what that basically means is that if it's a positive value, it means that it is above the line, and if it's a negative, it means it's below the line, and if it's 0, it means that the line is passing through. So we're seeing here that there's a very high, that our minimum, the first quarter, medium, third quarter, max, we see that there's a very big number for the negative, which means it's a far distance away, and then a smaller distance, and then we see positive distance and a big positive. So what we're seeing happening here is our data is far away in the below the line for the minimum, below the line for the first quarter. The median is below, but then the third quarter it crosses over. Coefficients. So here we go, our intercept. So let me just show you how this works. So it's just going back to y is equal to b plus b1 x1 plus b2 x2. You would know from math. So y here, the intercept is this number here. So that's the intercept. Then q1 will be here. So that's b1 is q1. So x1, and then negative is over there. So this now is the formula. So what you can do is you can punch an unknown square footage and unknown bedrooms, and we will get an estimation of the price. So let's just do that quickly, and we can do that right here in R. So let's imagine square footage is 1000, so let's have to multiply, and let's say that the bedrooms is 3. So if I now run that, we get that is what that is, which is that value there. So this model that we've created using this the line of code using that predicts that if we have a house of 1,000 square foot and 3 bedrooms, the price will be $202,000. So that's our prediction. If we use one from here, so let's just test, and I'll show you that our model is actually not very accurate. You see over here, square foot 2,104, and then 3 bedrooms. If I now run that, I get that as an output. 356,260, but it should be 399. So this over here is the actual, and that's the predicted. Can you see how they're not too far apart? This is 356,000 and it's 399. So they're not too far apart, but that's not very accurate. And we can see that if we come back here, the t-value basically tells you, let me just remind myself quickly, the t-value tells you whether you should drop the coefficient. And if it's bigger than 2, then it's good. So 9 is good. So our x2 is very good. That's a good coefficient. Sorry, our x1 is a good coefficient. But because it's between -2 and 2, our x2, that's not a very good coefficient. And the intercept is not bad because it's 2.1. It's not very good. So we know that our problem coefficients are that one and that one from that t-value. So we see that this model, based on the t-value, the residuals, the standard error basically tells us how precise it is. So it's the average distance to the line, and we see they're very big. See, these are very big numbers, even for that. So we're seeing here that this, well, actually 14 is not too bad, but these are very big, and it makes sense because this one's between -2 and 2, and it's a very big number. So this x2 coefficient is not very good, and our intercept is not very good. The only one which is actually quite good is this x1, which is this number here, 139.2. So we see this model is not very good, and that's basically, I would say, two things. The first thing being we need more numbers. We've only got 149 training rows to train our model with, and secondly, we need more features. But we were still able to predict a price of that when it should have been 399. We predicted 356,000, and so it's not too bad. So that's how you do multi-featured regression. It's simple. Well, it's not necessarily simple, but to get a very good model takes a lot of work and a lot of data, because obviously you have to clean this data first. So there you have it, multi-featured regression, and here's some code to help you along. I hope you have a fantastic day. Bye.